All right, welcome back everybody. Today taking a look at lesson 4.6, graphing reflections of points. So all of this is kind of culminating from the past couple lessons to graphing. Remember, our coordinates are x comma y, being our x coordinate, our y coordinate, and then we have to remember our quadrants. We have quadrant 1, which both coordinates are positive. We have quadrant 2, where our x coordinate is negative and our y coordinate is positive. We have quadrant 3, both x and y coordinates are negative. And then quadrant 4, x coordinate is positive, but our y is negative. So determining whether we're running or jumping to find our points. Now, exactly what is a reflection? And no, it's not, walking past your mirror and being terrified of what you see. With this, it is, the opposite or the mirror of the point that you have. So there's a couple different ways that we can say this, whether reflected across the x-axis or reflected across the y-axis or reflected vertically or reflected horizontally. So kind of like an example, if I have a point somewhere down here and it's saying reflect across the x-axis, I'm going to the opposite point. So let's just say, for example, this is, -2 comma -5. Sorry about the bell. So -2 comma -5. So then reflected up to the top, I'm still my x coordinate is going to be negative, but my y coordinate is going to be positive because I'm in this quadrant. So all it is being reflected over the top. Or let's say, for example, this coordinate, let's just say it's -3 comma -1, and it's saying to reflect it horizontally or across the y-axis. And then let's say over there we end up with 3 comma 1. I know the drawings aren't accurate, but that's kind of the idea of we're reflecting it over one axis or the other. So that's a reflection, not like our cute furry friend up top. Some examples, and I had this here, where if our starting point is point A, we're at -4 comma 5. So we're in the second quadrant, and they're telling us to reflect over the y-axis. We would end up with point B, and that would be 4 comma 5. And we're in the first quadrant, so we know both of our x and y coordinates are positive. Then, let's say from point A, they say reflect across the x-axis or reflect vertically, and then we would get -4 comma -5. So we're not moving in or out of the directions. It's literally a straight line, straight down or straight across. There may be times where they may say, reflect A across the y-axis, and then that'll be point B, and then reflect point C, reflect point B over the x-axis or across, or reflected vertically to find point, C, D, whatever. So then what you would have to do is reflect and then reflect down. So for example, if we did that, we would have 4 comma -5, so 1, 2, 3, 4, and then down 1, 2, 3, 4, 5. So our reflected, let's say this is point D, this would be 4 comma -5, and we would, give me 1 second, and then we would reflect this guy down. So in some instances, you may have a starting point. They may tell you to reflect somewhere and then reflect down. And then maybe they tell you to go one more time and then connect the dots. There's a lot of different scenarios that can happen there. So with these graphing, we want to make sure we're using our number sense. Like everything makes sense. Like if I'm going within my quadrants, I have to remember, you know, positive, positive, negative, positive. Quadrant 3 is the easy one because it's negative, negative, and then positive, negative. Whoop. Not -1, just negative, right? So understanding these, and then if we're going 1, 2, 3, 1, 2, 3, 1, 2, 3, 1, 2, 3, right? We want to make sure we know, you know, what point is where, and we want to, you know, count accurately from the origin, outward and up, or outward and up, or run then fall type deal. If we have fractions, we want to remember our kind of benchmark things, where if we have a unit fraction, remember that's a 1 over any number. So for example, like 1/2, 1/4, 1/10, those sort of things. So if you see a 1 in the numerator, it's a unit fraction. Benchmark fractions, these ones are kind of the easy guys. So 1/2, 1/4, 3/4, 1/3, 2/3, that sort of deal, the quick ones to remember. Understanding if it's improper or proper fraction. If it's an improper fraction, remember the numerator is greater than our denominator. Proper fractions, you know, it's basically anything that I've talked about before. If it's a mixed number, we have a whole number, and then let's say 4/9, right, for example. So we have our whole number and we have a fraction that is attached together. And going back to the previous lesson, for 4.4 and 4.5, that is a way for us to you know, determine where things are on a number line. We convert to you know, out of 100 and then change it to a decimal from there. Decimal, same thing. If we're at 3.2, we want to make sure that wherever we are on our coordinate graph, we're between, you know, let's go here instead of 3. Let's say I have 4, 4, 3, 2. I know it's not going to be in this area. So 3.2 is probably right about there, 3.2. And that's where my line, you know, my point would be, right? So being able to graph using your number sense is key. So thank you so much, and I will see you in the next video. Take care.